9, Section 1, Similar Right Triangles. The theorem in this section says that if the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. A reminder that the altitude of a triangle is going to go from the right angle, in this case, the altitude that we're talking about, will go from the right angle of the original triangle, and it's going to form two right angles on the hypotenuse. If you look at this example, it says a roof has a cross-section that is a right triangle. The diagram shows the approximate dimensions of this cross-section. In A, they ask us to identify the similar triangles in the diagram. First, we start with the whole triangle ABC, which would be my largest triangle. But then notice that for inside of triangle ABC, I have two smaller triangles. I have triangle ADB and triangle BDC. What I can do is I can write a similarity statement. Remember that when we're writing a similarity statement, the corresponding angle measures need to match up. So the similarity statement that I wrote, and there's a couple of different ways that you could write it. I started with the original triangle ABC. If you notice, it would be one of the acute angles. It's going to be the larger acute angle. B is the right angle, and then C would be my smaller acute angle in the larger triangle. If you look at triangle ADB, though, in this case, again, I have A would be that same larger acute angle. D, in this case, is going to be my right angle, so D has to be in the middle, just like B was in the middle of the first similarity statement, and then B, in this case, has become my smaller acute angle. And then if you look at the second triangle, BDC, B is now my larger acute angle, D is now the right angle, and then C would be the smaller acute angle. So similarity statement, they do not have to be in that order. It doesn't have to be ABC, ADB, and BDC. However, like if you said BAC for your first triangle, then the second triangle would have to be DAB, and the third triangle would have to be DBC. So there are other ways to write that similarity statement. However, the order does matter. The next example says to find the height h of the roof. If you look at the information that we're given about these triangles, first of all, we have three similar triangles. So to find h, I should be thinking about possibly using the setting up a proportion. So if you look at the largest triangle, triangle ABC, we know the hypotenuse and we know both the shorter and the longer leg. But if you look to find h, which would be the altitude, I'm going to have to set up a proportion, and I'm going to have to choose two of the triangles to use and set up and make sure that I have corresponding parts in corresponding places of the proportion. There are several different proportions that you could write here, so there's not one correct answer. However, I did 14.6 over 12.3 equals 7.8 over h. What 14.6 over 12.3 is, I'm using the biggest triangle, triangle ABC. 14.6 would be the hypotenuse, over 12.3 would be the longer leg. And then I'm using triangle ABD, and I'm going to say 7.8 is the hypotenuse, so it's on top just like 14.6 was on top, and then equals h because that would be the length of the longer leg in that smaller triangle. Just once you've set up your proportion, go ahead and cross multiply. We need to divide by 14.6, and we get h would be 6.6 meters. This next example says in the diagram, or the diagram shows the approximate dimensions of a right triangle. Again, A is asking us to identify the similar triangles in the diagram. I wrote my similarity statement as triangle RST, which would be the whole larger triangle, S would be my right angle, is similar to RUS, which is similar to SUT. Again, just like in the last example, order does matter here. If you look at the largest triangle, R would be my larger acute angle, T would be my smaller acute angle, and S is the right angle. So all of my right angles need to be in the middle of my notation. So for the other two triangles, notice that U is in the middle in the notation because U would be the right angle. And then R would be corresponding to R, T would be corresponding to T. B says find the height of the triangle. Again, I could set this up a couple of different ways, but if you look at the information that I'm given, I know the hypotenuse of the larger triangle, and I know the longer leg of the largest triangle. And then if you look at RUS, triangle RUS, H would be the longer leg, and 6.8 would be the hypotenuse. So this one's going to be very similar to the last example. I can set it up as 6.8 over H. In this case, 6.8 would be the hypotenuse of my smaller triangle, over H would be the longer leg of my smaller triangle, equals 14.4, which would be the hypotenuse of the largest triangle, over 12.7, which would be the longer leg of the largest triangle. Go ahead and cross multiply your proportion. In this case, I need to divide by 14.4 on both sides, and I get about 6 inches. The next example asks us to find the length of each variable. For A, we're asked to find x, which would be the altitude. If you notice in this case, I really don't know that much about this triangle. I'm trying to find the altitude. I don't know either one of the legs of the largest triangle here. I'm going to have to set up a proportion, and I'm going to have to use both of the smaller triangles to do it. The proportion that I set up, I said 6 over x. 6 would be the shorter leg, x would be the longer leg of the triangle on the left, and then x over 10, where in this case now I'm talking about the triangle on the right in A, and that would be x would be the shorter leg and 10 would be the longer leg. Now I need to cross multiply, and I would get 60 equals x squared. Take the square root of both sides, so you get the square root of 60, which can be simplified to 2 square roots of 15. If you notice in this example, I just took the geometric mean, if you remember talking about that, of 6 and 10. So I said we would kind of touch on that later, and that's what we just found in A. If you look at example B, I am given that one of the legs of the whole triangle is y, and then I know one of the segments created on the hypotenuse is 5, and the other that's created is 8. In this case, the proportion that I set up was 5 over y. If you look kind of how the triangle is divided into a kind of a top triangle and a bottom triangle. On the top triangle, 5 would be one of the legs, and y would be the hypotenuse. And then I set it equal to y over 13. Y would be the leg of the triangle, and 13, I get 13 by adding 5 plus 8, which would give me the hypotenuse of the largest triangle. When I cross multiply, I get 65 equals y squared, which gives me y equals the square root of 65. Again, notice that that was the geometric mean of those two numbers. This next example is very similar to the last example. It asks us to find the value of each variable again. They're going to be very similar. If you want to, I would suggest pausing this video and going ahead and trying to do them on your own, looking at the last example to kind of help you. For A, I'm just going to go through this a little bit quickly, but it's going to be very similar to A on the last example. I set it up as 24 over x equals x over 14. There's not one right way to set up these proportions, by the way. There's several different ways, but when you cross multiply, you should be multiplying 24 times 14 and x times x. Where I got 24 and x is on the triangle that's created by the altitude kind of on the left side of the triangle on A. 24 would be my longer side, x would be my shorter side, and then I set it equal to, in the triangle created on the right, x would be the longer side and 14 would be the smaller side. So go ahead and cross multiply. We get 336 equals x squared. Take the square root of 336. Remember, we want to simplify our square roots. That square root simplifies to 4 square roots of 21. B is very similar to B in the last example. I set up this proportion by saying 23, which I get by adding the 5 and 18, which gives me a hypotenuse of the largest triangle to be 23. So I have 23 over y, which would be the hypotenuse over the longer leg, equals y over 18, which would be the hypotenuse over the longer leg of the triangle that's created by the altitude kind of on the bottom or right side of this triangle. Go ahead and cross multiply, and you get 414 equals the y squared. Take the square root of both sides, and you have the square root of 414, which simplifies to 3 square roots of 46. Today's assignment is on page 531. It's numbers 2 through 30 even.